Hi, everybody. I want to welcome you to the first section of notes. This is, the notes in this section are going to be divided into two short videos. One will be longer than the other. So this is the section where we introduce problem solving and some of the different problem solving methods that we're going to use as the course continues through the semester. So as the directions in Canvas say, as we work through problems here, pause. Try them yourself, okay? Think through them. If we were in a regular classroom, that's what we would be doing. So don't deny yourself that chance here. If you have questions as you work through, or if you're having issues with the recordings, let me know. And let's get started. So I'm going to share my screen. Okay, so you should be able to see the introduction to problem solving right here. All right, so we're going to jump right into this with our very first problem. We have this person, imagine, and they are taking 2 eggs at a time from a basket, and then that basket has 1 egg left when they're done. And then somebody else is taking eggs 3 at a time from a basket, and then they have 2 left. And then the person puts them all back and starts removing them 5 at a time and has 3 left. So what's the fewest number of eggs possible in the basket? I don't know. Well, there are some things to ask yourself before you go too far here. First, do you really understand what the problem's asking? Well, ultimately, what we're trying to figure out here is how many eggs are in the basket. What's the fewest number that could be, and have this story be true? And then think about the different strategies you could use to solve this. You could make a picture, you could make a chart, you could write an equation. I'm going to do it a little differently from that, actually. But this is the point where you should pause and then go try it. Okay, so hopefully you took a minute to try it. So then let's see how this goes. I'm going to move my screen a little bit and get my pen. All right, so I'm going to start here at the 5 because sometimes I want to start with the biggest number. It seems to make sense here. So for me, I have a basket of eggs. I'm going to take out 5 and I'm going to have 3 left. Well, 5 and 3 is 8, so maybe I'll start with 8, okay? So if I have 8 eggs, I take out 5. I have 3 left. That's good. Worked out. If I have 8 eggs, let's try the next category. I take out 3 at a time and I have 2 left. All right, well, let's see what happens. If I have 8 eggs, I take out 3. That leaves me with 5. Oh. If I take out 3 again, that leaves me with 2. That's a good thing. Check. All right, now let's do the last one. I have 2 eggs I'm going to take out of the time from the basket. I'm going to have 1 left. Take out 2, I get 6. Take out 2, I get 4. Take out 2, I get 2. Take out 2, I got none. Boo, that's not going to work. But I did actually learn something here, so pause and think for a second. What did we learn? I learned that the number of the eggs in the basket can't be even, right? Because by definition, even numbers are counting by 2s. So if I'm taking 2 eggs at a time out of the basket and I need to have 1 left, it's got to be an odd number of eggs. So that's good to know. All right, well, 8 didn't work. Let's erase that. And now let's try something else. Well, let's see. Let's think about what we could try next that would be smart. I was going to start with the 5. So I started with 8. Maybe I want to take out another group of 5. So 8 and 5 is 13. Maybe 13 will work. Let's try it. So if I have 13, I can take out 5, and that's going to give me 8. I'm going to take out 5. That's going to give me 3. All right. If I have 13, now let's try taking out 3. Let's see where we get. If I take out 3, I get 10. If I take out 3, I get 7. If I take out 3, I get 4. Uh-oh. If I take out 3, I get 1. Nope. All right. Well, 13 didn't work. Well, let's try something else. Maybe if I add 13 plus 5, another group of 5, let's see, that would get me 18, right? But 18 is even, so that's not cool. We're not going to use that one because I know it's not going to work. No point in doing the work for it, right? All right, so let's try what comes after 18. 18 and 5 is 23. Let's try 23. All right, so if I have 23, I take out 5, that gets me to 18. I take out 5, that gets me to 13. I take out 5, that gets me to 8. I take out 5, that gets me to 3. Cool. I can take out 4 groups of 5. All right, let's try 3s. If I take out 3, that gets me to 20, right? If I take out 3 again, that gets me to 17. 3 again gets me to 14. 3 again gets me to 11. Ooh, I like this. 11, take out 3, gets me to 8. Ooh. Take out 3 more, gets me to 5. Take out 3 more, gets me to 2. Hooray. Well, and here's the thing. 23 is odd, right? I don't even have to figure out 2. Because I know if I take 2 at a time away from an odd number, eventually I end up with 1. So I could take, let's see, 23. 2 times 11 is 22. I could take 22 eggs out of that basket, all right, and end up with 1 left. So 23 is the answer here. Now, could you have done this differently and had it totally work out? Absolutely. Could you draw a picture? Could you have guessed and checked or done things in a different order? For sure. And kids in a classroom will do the same thing. But you got to start somewhere, and that's the trick to this. Don't ever be afraid to start, okay? So we're going to talk a lot in this class about problem solving. And problem solving is really about doing something where you don't know the right way to go forward. That's what happens when you're presented with a problem. You think like, what do I do now? Happens in math, happens in life, happens all the time. So in order to find a solution, you have to think like, okay, what do I know? What do I know how to do? And where am I going to end up? And this is where you learn something new. It might be math, it might be how to fix your car, it might be all kinds of things. Solving problems is not only a goal, right? Because getting the solution is great, but it's a means. So when we teach kids how to solve problems in math, we're giving them not just math skills, but we're giving them life skills, right? Sometimes it's less about the answer than about the actual process, because the process of problem solving really matters. When you give kids those tools, you prepare them to face whatever kind of problem comes in their path. All right, so the definition of problem solving according to Common Core is that mathematically proficient students start by explaining to themselves the meaning of a problem, and then they look for a solution. So before you can start looking for a solution, you have to say like, oh, hey, what am I trying to figure out? Which is a good place to start. The other thing to be aware of if you're not is that Common Core has what's called the mathematical practice standards. The practice standards are, at least to me, more important in a lot of ways than the content standards. Like, you know, you have to learn to add and multiply and do all those things. What matters is building the process skills, the how you do math, the how you solve problems, the accuracy, the precision, the finding patterns. Those are all process skills here. All right, so you can find those at that link in the math practice standards. So when does a student use their mathematical problem solving skills? Well, when they're presented with something that they know, they understand the problem, but like they don't know what to do. How do you find the solution? Or when they're interested in solving something. So sometimes they see a problem, they think like, I'm gonna figure that out. So then they use their problem solving skills. Or when you say to them, okay, we're gonna apply this math that we're using right now. We're gonna use it to solve a problem. Okay, it's application based. All right. So one of the ways we can teach problem solving is through puzzles, and others through games. We're going to play some games here, even though we're online. One of the kinds of puzzles that you can use to teach problem solving is called Uidoku. Basically, the way I think of this is some math teacher was sitting around their house doing Sudoku puzzles and went like, oh, I can make this a math lesson. And they did. If you've never played Sudoku, the idea is you make each column down, okay, the same 4 numbers, and each row across the same 4 numbers, but you don't repeat those numbers in any row or column more than once, okay? So the first thing we have to figure out is what on earth, what numbers are we using? And that's what the clues in the puzzle are for. So in this one, this tells us this square equals 9. Well, fantastic. This square equals 9. This square equals 4. This square equals 5. Lovely. Here's the problem though. I need 4 numbers. I only have 3. So I got a 9, I got a 4, and I have a 5. Well, super. Now what? And if you haven't paused and tried this yourself yet, maybe you should. All right, so, well, here's this third row down helps me, right? Because I know that all 4 numbers together have to add up to 25. That's what that little 25 means. So I can use that. Okay, I need it to be 25. Well, 9 and 4 is 13, plus 5 is 18. 25 minus 18 is 7. So my last number is 7. Okay? Now here's the thing. I can't put a number in a column more than once or in a row more than once. But I'm not sure I have enough information right now to fill in what goes in this column of, or sorry, row of 25. But I can do some other stuff, right? Like I can use this 11 because I need to make 11. It's got to go in these 2 boxes. But here's the thing. Out of these numbers, there's only one way to make 11. Do you see it? It's 7 and 4. And since a number can only appear once in each row, the 4 has got to go up here because that has to be a 7. It can't be a 4. All right, so progress. Now, let's see. What do I want to do next? Now, there has to be some sort of guess. Like you have to make an educated guess, and if it goes wrong, it goes wrong. You just fix it. You try again. That's what problem solving is about. So let's see. I know, maybe I'll work on 4s. I know that I have a 4 in the first row, a 4 in the second row. I need one somewhere in the third row and in the fourth row. And I know I need a 4 in this column and in this one. So let's see, maybe I'll just put the 4 here and I'll put the other one here. And we'll see what happens. If it works out, it works out. All right, but now that helps me. So like I have all the 4s figured out. Now what can I do next? Well, now I'm going to use some places where I know some stuff. Well, let's see. I have a 4 and a 7 in this column. It means I need a 9, in this row. It means I need a 9 and a 5. But I already have a 9 going down. So this has got to be a 5. And this has got to be a 9. All right, well, that's progress. This column has everything but a 7. Cool. Now this column also has everything but a 7. Cool. And look, 3 7s. 1, 2, 3. That means my last 7's got to go here. Let's see. 4, 7, 5. That's got to be a 9. 4, 7, 9. That's got to be a 5. And look, it just sort of falls into place. And now take a look. I have 9, 7, 5, 4. It all worked out. So there are more puzzles like these. You can read this article in SmartBrief about it, and actually then inside of this article there's a link to Edutopia, and it gives you a link to Ouidoku puzzles like this. It's worth taking a look at, and it talks more about the value of problem solving. So this is the first short video. I'm going to stop this one here so that we can, the second one will be a little bit longer. It's more about strategies. The notes, the completed notes for this section are all going to be in one document. Okay, so I'm not going to break them up with the videos, just so you're aware. All right, so I'm going to stop this one here, and then I'm going to start the next one. Join me there.